Okay, so we're going to go on with more light, specifically white light and elemental line spectra. So what does that mean? Well, white light, that's kind of a weirdness. We've talked about that to make light, we've got to transfer energy to an electron. The electron kind of travels farther away from the nucleus, then it relaxes and releases that energy as light. Well, every time it relaxes, it can release one beam of light, one photon of light, so it can release one color. So if you want multiple colors, you've got to have many atoms going through this process all at the same time. Well, there are many atoms out there, and there are some places where many atoms are having a lot of energy transferred into them, so they can actually release white light. Well, what white light is all of those wavelengths from that 380 to that, that purple 380 to that red 750, all of the wavelengths between emitted at one time, that will give us white light, which is why when you put white light with a prism, the colors separate. This prism sort of acts as a filter. What it really does is it changes the path of each of the wavelengths. Beams of light with a lower wavelength, that it changes their paths more. So you can see that it is kind of, if you consider the white to be driving along, well, it veers off to the left here. Well, prisms, they don't alter the higher energy wavelengths as much, so the purple is pretty much staying on track. It's moving a little bit, but not so much. So this prism is filtering the light into its different wavelengths so we can see. If they're separated, they look like the pretty rainbow, but if they're all together, they look like white light. Great. What does that have to do with atoms? Well, because atoms have, unique numbers of protons and unique numbers of electrons, there's different places where electrons are pulled at different strengths, which means when you add energy to them, sometimes the electrons, depending on what atom it is, sometimes the electrons will go a certain distance, sometimes they'll go much farther. So each atom has its unique place where the electrons will go if you add energy to them. Well, since those unique places are all different distances, every time one of those electrons comes back, it will release a different beam of light. So this is called the line spectra for the element that we're referring to. So if we have hydrogen here, you can see there's 1, 2, 3, actually, let me see, can I move this at all? Yeah, you can see, well, it's like right on the line. Oh, there we go. So you can see 4 of the colors that hydrogen releases. This one's got a really high wavelength, and it's a warm color, it's our red. This has got a low wavelength, it's our purples. Neon has a completely different array because when you add energy to an electron in neon, there are different places it goes different distances, and when it comes back, it releases a different amount. So there are specific locations for neon, and those are different than hydrogen. And then iron, look at this guy. This guy's got a bazillion places that it goes. Well, so what does that mean? Does that mean when we give energy to hydrogen, we get to see 4 colors? Not quite. What we get to see is the blending of all 4 of those colors. Can I move myself out of the way there? So this is helium. And so helium gives us this warm yellow-orange color, but it's not because it's got one color that it's emitting. It's emitting all of those different colors because all of those electrons are bouncing up and down between those 2 places as long as we're giving it energy, which is what we're doing here. And this is true of neon and argon and krypton and xenon. All of these guys have the same type of story going on. So we're not seeing all of the colors, we're seeing the blending of color. Just like white light is a blending of all of the wavelengths, what we see here is a blending of the specific wavelengths that these elements can emit. And so, let me try this again. This is our periodic table, and instead of having the bottom 2 rows cut out and put at the bottom, they just kind of stuck them in here. So this is the long form of the periodic table, and it has the line spectrum for all of our elements. So we can see titanium here is very colorful, and our hydrogen is kind of hard to see, but it only has those 4 lines, and we've got carbon with a few more, and nitrogen a few more, and it seems like phosphorus has got a lot going on in the green and blue region. So every single element has a different line spectra. We can identify the element by its line spectra. And so it's a unique quality that each atom possesses, and it's one way that scientists actually determine what's going on other planets. If we get light from another planet or another sun or whatever, and then we filter it and we get specific lines, we can see what atoms are on that planet. It's kind of a cool trick that these chemists and physicists do to check out what's going on in other places. So, I hope this helps. Struggle well.